Well, Alejandro is a PhD student from Buenos Aires, and he's going to talk about, well, my title doesn't match yours, so
Yeah,
maybe
yes, yes, yes. I apologize for that.
okay. You introduce yourself. Do you want me
Yes, yes, yes.
to let you know when 5 minutes when you have
Okay,
5 minutes
perfect.
less or not? Okay, great.
Yes, yes.
Take it away.
Okay. Thank you, Pedro. And well, I want to thank the organizers for not only for this opportunity, but for the very nice meeting they organized. This meeting is already a classic for the community, and it's very important for PhD students in Latin America and junior postdocs. And also want to apologize for changing the title of my talk. The original
Can you make full pantalla? Because
oh, yes, yes, yes. Sorry. Okay,
very good.
sorry, sorry. Okay. Yes, I want to apologize for changing the title of the talk. The original title was the title of the first this series of works in collaboration with Eric Lescano and Gabriel Meneses. As you can see, the second and the third work are very recent, so I applied to the talk before these works appear. So I'm going to talk to you about T-duality and alpha prime corrections via double copy, and I'm going to follow this outline. At first, I'm going to talk to you about our motivation behind this work, which is to obtain higher order corrections from models that include T-duality in a manifest way. To study that, the ideal framework is double field theory, which turns out to be the double copy of Yang-Mills theory, as I will tell you later. And next, I'm going to talk about how, following that approach, the double copy procedure, we can obtain four derivative theories in the double space that contains conformal gravity and make us think of a kind of conformal double field theory. And finally, I will present a theory with alpha prime corrections that at perturbative level can be obtained through the double copy procedure. So I start talking about our motivation. And well, it is well known that at low energy, string theory can be described by a particle theory, the supergravity, whose action at leading order is given by this action that contains some fundamental fields, the metric through the scalar curvature, the dilaton, and the Kalb-Ramond form, which appears in its curvature. And one consider stringy effects that corrects the leading order action. And these effects appear in a perturbative expansion weighted by the parameter, which is the string length, alpha prime. And these corrections are higher order terms in higher order in derivatives. So the leading order has two derivatives, the first order correction has four derivatives, the second order has six, and so on. And for the first few terms of expansion, these terms are well known. And in particular, I want to highlight the first order corrections to bosonic supergravity, which are given by the square of the Riemann tensor. But well, this expansion is strongly constrained by the symmetries of string theory. And in particular, it was shown by Maharana, Schwartz, and Sen in different works that T-duality is an exact symmetry at all orders in the expansion. So taking this into account, we are interested in working in a framework that includes T-duality as a manifest symmetry, and this framework is double field theory. This theory, as I mentioned, includes T-duality or the ODD, the symmetry group of T-duality as a manifest symmetry, but you must double the space-time dimension. Of course, there is a condition that I will call the supergravity limit in this talk, and I won't explain it in detail, but there is a condition that connects double field theory with the known supergravity theories. So in the last, I don't know, 10, 12 years, there have been a lot of advances in the computation of alpha prime corrections in the context of double field theory, but there seems to be an abstraction to obtaining all the cubic order from this approach, in particular, these ones which has this zeta function as coefficient. So it's necessary to look for new methods to calculate alpha prime corrections. And in this way, a useful tool could be the double copy procedure stated by Bern, Carrasco, and Johansson, which is an approach that exploits a duality between gauge scattering amplitudes and gravitational scattering amplitudes. It is possible to factorize some gauge scattering amplitudes in a way that by interchanging some color indices by kinematic indices, one can obtain gravitational scattering amplitudes as gauge square scattering amplitudes. So if so, this duality is valid at the level of scattering amplitude, and there is no reason to expect that features of the double copy procedure can be seen at the level of an action. There have been several attempts to achieve this, and one of special interest for us is this work by Díaz Jaramillo, Hom, and Plewka, in which they start with the Young-Mill action, and they expand the action in up to cubic order in fields. So this is the quadratic expansion, and this is the cubic expansion after some integrations. And after that, they go to momentum space and obtain these two expressions for the quadratic and the cubic action of Young-Mill theory. And we can inspect in a naive way these actions, and we can see that there is, well, there are gravitational indices by one side, gauge indices in the other side, and well, it appears also these objects pi mu nu and pi mu nu rho, which depends on the momenta. So the proposal by the authors in this work is to replace some of the gauge quantities in the same spirit as the double copy for scattering amplitude. And what they said is that they're going to replace color indices by a new set of gravitational indices, which are denoted by some bars. And they also duplicate the momentum space, introducing new momentums k bar. So the replacements are, well, the gauge fields are now some field line. The Cartan killing metric is replaced by the p mu nu, but for the bar momenta, and the same for the structure constants. And with this replacement, the action for at quadratic, even at cubic order, take this form. And one can see that there is now a symmetry between the barred momenta and the unbarred momenta, and also between the two sets of gravitational objects. And the interesting here is that, well, after expanding this action and coming back to the configuration space, to the coordinate space, the action they obtain is the quadratic and cubic order actions for a perturbative double field theory, up to a gauge fixing condition. So here they define the generalized dilaton of double field theory in this way. And well, based on that, we wonder if there are higher order gauge theories that, after the double copy procedure, lead us to a double theory that contains interesting alpha prime corrections in the supergravity limit. So trying to answer this question, we start with this model, this theory, which is a four derivative gauge Lagrangian that contains as fundamental fields the standard gauge fields in the general representation of a gauge group, and a Church scalar field that lives in a different but real representation of the same gauge group. The action contains also other objects like structure constants, some generators into the covariant derivative, symmetric objects, and well, I highlight the Clebsch-Gordon coefficients that links the two representations. And we start from this model because it is known that in d = 6 and for particular values of the coefficients, this Lagrangian is the double copy of conformal gravity. It was computed at the level of scattering amplitude. So what we did in the first work was to set the A2 up to A5 coefficients to 0 and work just with the first term. As we can see, this is the Yang-Mills curvature and only contains the gauge field, so we don't worry about the scalar field in this work. And we applied the same double copy that Tom and others proposed. And after, well, as we know that this theory is linked in some way with conformal gravity, we also explore the conformal gravity action, which is given by the square of the Weil tensor defined in this way. So what we obtain after applying the double copy is, well, we work up to cubic ordering fields again. And what we obtained, for instance, at quadratic order was this action in the double space. Watch this action that matches the conformal gravity action at the same ordering fields when we take the field line as the perturbations of the metric and we set to 0 the other massless fields of supergravity. Both action matches if we impose this gauge condition, which is related to dilatations in CGS spatial dilatations. So we obtain also similar but complicated expressions for cubic terms, and our results summarize as well. We could construct a theory that contains conformal gravity and supergravity in the supergravity limit, but requires a gauge fixing condition. And there is nothing wrong about have a gauge fixing condition, but if we can think on a non-perturbative construction, maybe it's good to have a theory gauge independent. And well, there is a negative result is that we have extra cubic terms in the action. So we have to work on these cubic terms and to solve it. In this recent work, we work with the full action, which now requires a double copy map for the scalar field and objects related with that representation of the gauge group. Here I show the double copy map for the scalar and for the Cartan killing metric. And in summary, the results in this work, the procedure is the same. We apply the double copy map, expand the action, and we wrote an action in the double space. And that action reduces to conformal gravity in the supergravity limit again, without the gauge fixing condition and without the cubic extra terms. We were able to fix the value of the coefficients, of course. Interestingly, A2, A3, and A4 are proportional to A1, which depends on the dimension in this way. And interestingly, it vanishes for d = 3, what is expected for conformal gravity. I have to mention that in this work, we set the generalized dilaton contributions to 0. And because of that, we cannot fix the A5 coefficient. And well, at this point, we have learned that Young-Mills is the double copy of double field theory, and that there is a higher order gauge theory that whose double copy contains in some limit alpha prime correction. In particular, conformal gravity, but conformal gravity is a four derivative theory, so it could be related to alpha prime corrections of some supergravity theory. So with this in mind, we prove in
5 minutes.
thanks. We prove in this recent work that the combination of Young-Mills and our higher order theory, here I wrote the A1 and A2 contributions, but it applies for all the action, lead us to a perturbative formulation in double space, which is called DFT plus. DFT plus is given by this action where the highlight terms are maybe the physical terms. The first one is the leading order action of double field theory, and R minus and R plus are higher order contributions, which are related in this particular combination to the alpha prime corrections of bosonic supergravity. We also include a couple of terms in the action that are proportional to the equations of motion and could be removed by performing some field redefinitions, but for our purposes is nice to explicitly write these terms in the action. And well, if we parameterize this action, taking the supergravity limit that I mentioned at the starting of the talk, the action reduces to this expression, which contains the leading order action of supergravity and contains these four derivative terms, in particular the Riemann square term, which are the alpha prime corrections of the bosonic string. Contains a matter content related to the form and the dilaton, and these two terms, which again now in supergravity are proportional to the equations of motion and could be removed. But if we don't remove these terms, all this combination, these first three terms, are the Weil tensor squared. So in particular, we looked at for B equals 0 and the dilaton equals 0, the action we obtain is the supergravity action at leading order plus Weil gravity, as we obtain from the application from the double copy map to our gauge theory. So let me finish with some conclusions. In this series of work, we could prove that the double copy methods are a very powerful tool in the obtention of alpha prime corrections. These results also highlights the existence of a connection between gauge theory and higher order T-dual invariant models. And finally, open new research lines like the search for new higher order structures in double field theory, as also as such the study of the relations between gauge theories and gravitational theories at the level of the equations of motion with the so-called single and zero copy. Well, thank you very much. Have 1 minute.
Okay, Ale, thank you very much for the talk. We have he actually had 1 minute left, so we have actually some extra minutes for questions, please.
Oh.
Arpan.
I have like a couple of silly questions. So the first one is like the BCJ or the original KD, like both. I think both of them like say that like relating scattering amplitude in the same dimension, right? Like Young-Mills, two copies of Young-Mills give you the gravity amplitude in the same dimensions, right? And here,
I'm sorry, I couldn't hear you.
So actually, so I'm a bit confused about this doubling of dimension. So this BCJ double copy, that thing gives a statement about the scattering amplitudes, Young-Mills scattering amplitude, two copies of Young-Mills scattering amplitude in D dimension, and produces a gravity amplitude in D dimension itself, not the 2D dimension, right? But here you have a doubling of dimension, so I'm a bit confused.
Arpan, are you there?
Yeah, and
Okay.
Okay. Maybe, Ale, did you catch that? Maybe your microphone is a little bit off.
Can you hear me now?
No, yes.
Okay. Yes, I'm not sure about the answer to that question.
okay.
Yes.
So another question is that so I mean either yesterday or day before yesterday there was some talk. There the speaker was saying that there is this higher gauge theories like where this higher gauge theories are related to higher categories and all these things. So the kind of like higher double fit theories you are talking about,
Mhm.
are they somehow related to this higher categories or not? I mean, this is just hunch. I mean, just like layman's question. I mean, don't take it seriously.
Yes. They are clearly related, but something we are exploring, and I think maybe it's not a positive result, is that there is no way to construct a double a theory in the double space, uh, which could be only a higher derivative theory. It must contain in every case it must contain the leading order action. So yes, there is no way to have a higher order gauge theory related to a theory like double field theory, just with four derivatives, for instance.
Okay, thank you.
Okay, I don't know if Nana or Mati. I don't know who's first.
It seems Matthias was first, but it's okay. Yeah, I can ask. So mine is a very simple but generic question. Thank you very much for your nice talk. But so people know what is the double copy of the standard gravity. I mean, let's say just GR with cosmological constant, or is there a way of trying to get that?
Yes, I'm not sure about. I'm not an expert on the side of double copy. I work on double field theory, and in fact, I don't know anything about amplitudes. But as far as I know, there are a lot of improvements in the understanding of solution of black hole solutions. But concerning cosmology, there has no any advance. So. About including the cosmological constant, I'm not sure.
Okay.
I guess no. As far as I know,
No, but
there are
there
no.
are double copy statements about cosmological correlates.
Can you repeat what you said?
So I mean I cannot say on the head the reference or something, but uh, I mean cosmological correlated level there are statements about double copy, like for example scalar gauge field correlator and scalar T-mu correlator, they are
Okay.
related by some sort of double copy and all. But I don't know in like some non-productive question and all. I don't know.
Okay.
Thanks.
Okay. Well, thank you. Interesting. Yeah.
Yes, I didn't know.
Alejandro, you were talking about a supergravity limit, but
Yes,
you made a particular choice. But
yes.
if you didn't make this choice, you have supergravity in all the big term, or only making this choice.
Yes. Well, I I was maybe very weak at talking about this limit. When I talk about supergravity limit, is the strong constraint in double field theory, which is a particular solution that matches the double space with supergravity theories. And after that, we also set a particular limit, which in the papers we call the pure gravity limit, in which we set to zero the two form and the dilaton, and we as this is a perturbative exploration, we set the field line equal to the perturbation of the metric. So these are the two limits that we are taking into account.
You don't do the double couple with the other terms in the multiples, like the...
In principle, we have the full double structure, the double space structure, and we can write all the, but also the perturbation of these fields, the dilaton and the two form. So in principle, we know it, but there is a lot of terms, and we at this point are interested in obtaining the gravitational side of it, in particular the Riemann square terms.
Okay, thank you.
Thanks to you.
Okay, so we thank Ale again. This last talk